8 million pieces of plastic are thrown into the ocean every single day. That's one garbage truck filled with plastic every single minute. And at the end of this presentation, 3 garbage trucks would have polluted the ocean. This isn't just an environmental problem, it's a global crisis. And traditional solutions simply aren't enough to keep up with the rate of plastic pollution. And so, instead of just cleaning up plastic from beaches, why don't we just break it down from its source? Here's our plan. Think of plastic like stubborn chains. They're strong, unyielding, and get tangled up in the ocean. Now, imagine our solution as microscopic locksmiths. They take these plastic chains and they break them down. Using CRISPR, we plan to give the bacteria Pseudomonas putida a serious upgrade. We plan to make them eat and break down plastic. I mean, how cool is that? And to do so, we have to put 2 enzymes into its DNA. PETase is basically the DNA that takes these long plastic chains and breaks it down into smaller fragments. And METase takes these smaller fragments and turns them into more digestible and easily handleable microscopic building blocks that can also be recycled and used in cosmetics, pharmaceuticals, and sanitization, creating a more sustainable cycle of resources on our planet. And we put these enzymes through AlphaFold 3 to see how viable they would be in our world today, and we got a 90% rate of accuracy, meaning that this can be implemented with a high success rate. But here's the cool part. We aren't just going to throw the bacteria into the ocean. I mean, that's like throwing bees into a field and expecting them to make honey almost immediately. Instead, we're going to deploy them in something called floating bioreactors. They're kind of like high-tech greenhouses that we plan to put in the middle of plastic hotspots, like the Great Pacific Garbage Patch, that have the bacteria in them to eat the plastic. And so the bioreactors work like this. They're kind of like a conveyor belt. They pull plastic from the ocean, and then the bacteria work their magic with optimal temperature, oxygen levels, and pH levels, and then they produce these invaluable byproducts. But in the case of these bacteria leaking out from the bioreactors, we're going to make them accustomed to a specific nutrient that will only provide in the bioreactor. And so if they do leak out, they'll lose their function almost immediately without the nutrients. But like any technology, ours also has its limitations. And the main problems plaguing our technology is scalability. It's currently not developed enough to tackle such a global problem like plastic pollution. And we have limited access to technology as well. And it costs almost $10 million to implement one bioreactor. And so in the future, we would like to streamline the implementation and operation processes of bioreactors to create a sustainable future without plastic pollution. And so harvesting and harnessing the natural capabilities of microorganisms will allow us to break down plastic in a more eco-friendly way, and implementing solutions today will allow us to create a brighter and greater tomorrow. Thank you.